Welcome to the Introduction to Energy Management Training, Module 1. In this module, we will be discussing energy basics. Energy basics can be broken down into the definition of energy, forms of energy, flow of energy, and the measurement of energy. The definition of energy. The definition of energy is a measure of the ability of an object that can result in the performance of work. Remember, work is measured in joules. Energy has a quantity and energy has a quality. For example, 3.6 being the quantity and megajoules being the quality. How we know that energy exists. Energy can only be observed by its effects. In a class discussion, please discuss the following points. How can you experience energy? How can you measure energy? How can you capture and or store energy? What percentage of energy do you pay for? Can you change energy and how? Starting off with how you can experience energy. Energy can definitely be seen and felt. Imagine being electrocuted. You would definitely feel the energy rushing through your body. How can you measure energy? Using electrical energy as an example, you can measure energy with a power meter and obtain the kilowatt hours. How can you capture and or store energy? Energy can be captured and stored in terms of, for example, air can be stored as compressed air in a compressed air vessel. Chemical energy can be stored in batteries, and thermal energy in hot water storage tanks like a geyser. What percentage of energy do you pay for? This will be discussed in a bit more detail on the next slide, but the short answer is 10%. And can you change energy and how? This brings us back to the first law of thermodynamics, also known as the law of conservation of energy. And it states that energy cannot be created nor destroyed, but energy can be transferred from one unit to another. For example, water being frozen and turned into ice, or potential energy of a ball hanging in the air and being dropped being changed into kinetic energy. What percentage of energy do you pay for? If we have 100 units as an input as coal into a power station where we lose 70%, we lose 9% approximately on distribution losses, 10% approximately on motor losses, 2% on drivetrain losses, 25% on pump losses, 33% on system losses, and 20% on pipe losses, leaving us with approximately 9.67 units. Energy effects, macroscopic, static. This translates to potential energy. Potential energy is static, it's stored energy, it's waiting to be released or deployed. For example, gravity pulling, chemicals in a battery, a stretched rubber band or spring, or chemical food conversion. This energy is due to a potential difference and requires a reference base or position from where the energy can be measured. Energy effects, macroscopic, dynamic. Kinetic energy is a dynamic energy interactions in an organized movement state. Examples are waves of heat from a fire, sound waves from vibrating speaker, an accelerating car, or pushing a wheelbarrow. Kinetic energy is always positive and is associated with force and movement. Energy effects, microscopic. Microscopic or internal energy is related to the molecular activity and structure. It is energy associated with activity and energy associated with binding forces. When looking at energy associated with activity, Sensible energy is of the consideration, where average velocity and a degree of activity with regards to temperature occurs. Moving or translational, like gases, rotating or vibrating and spinning. When we look at energy associated with binding forces, it's usually latent energy. It's mostly no change in chemical composition, only relative positioning. For example, gases, liquids, and solids, with gases being the weakest, liquids medium, and solids the strongest bonds. To summarize, latent energy is related to changes in phase, where sensible energy is related to changes in temperatures of a gas or object with no change in phase. The total energy in a system is a combination of the macroscopic and microscopic energy plus minus additional energy sources. Under macroscopic, we've got potential, kinetic, and mass as energy flows, whereas microscopic falls with internal and plus or minus additional energy. At the end of the day, we look at potential and kinetic energy plus the enthalpy.